Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars, study manuals, for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today for exam LTAM. For a group of 100 lives, age X with independent future lifetimes, you are given each life is to be paid 1 at the beginning of each year if alive, so they all receive an annuity due, life annuity due. Big AX is equal to 0.45. The second moment of present value of life insurance, random present value of life insurance, is written as 2AX is 0.22. Interest rate is 5%. Y is the present value random variable of the aggregate payments. Using the normal approximation to Y, calculate the initial size of the fund needed in order to be 95% certain of being able to make the payments for these life annuities. And here's the solution. Let us write U for the random present value of a life annuity due on an individual life age X of the 100 considered. And Y is the sum, Y is a sum of 100 independent, identically distributed random variables, all with probability distribution that U has. That's basically what the problem says, although not directly, but you're supposed to infer this from the problem. This implies that once we determine the mean and variance of Y, we will be able to approximate it with a normal random variable with the same mean and variance as Y, because of central limit theorem. And after Y is standardized, so that we subtract its mean divided by its standard deviation, it can be approximated by a standard normal distribution. For each life, the expected value of all future payments to be made is E of U, which is A double dot X, which is 1 minus AX over D. That's 1 minus AX over I divided by 1 plus I. So 1 plus I times 1 minus AX over I. And that's 1.05 times 0.55 over 0.05, so 11.55. While the variance of a random present value of all future payments to be made is the variance of the random present value of a unit life annuity due, which equals a variance of U, which is 2AX minus AX squared over D squared. And D is I over 1 plus I, so we write it as such. So this becomes 0.22 minus 0.45 squared over 0.05 divided by 1.05 squared, and that's approximately 7.7175. Therefore, E of Y is, which is 100 E of U, is 1,155, and the variance of Y, which is 100 variances of U, is 771.45. Let us write F for the initial size of the fund needed to be 95% certain of being able to make the payments for these life annuities. If we use the notation Z for a standard normal random variable, then we have 0.95 is the property that Y is less than F, which is the property of Y minus E of Y divided by square root of variance of Y, being less than F minus E of Y over square root of the variance of Y, and that's equal to approximately, but for practical purposes of this problem, we can just write this as equal based on central limit theorem. This is the property that Z is less than F minus E of Y over square root of variance of Y. Since the 95th percentile of the standard normal distribution given in the table is 1.645, we conclude that 1.645 is equal to F minus E of Y over square root of variance of Y, so F minus 1,155 over square root of 771.45. So 1.645 is equal to this expression. From this we solve it for F to be 1,155 plus 1.645 times the square root of 771.45. approximately 1200.6899, which is answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.